Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. Good evening. So now that the syllabus for term 1 and term 2 has been announced, we know that quadratic equations is a part of term 2 portions, not term 1. We have learned sufficient in quadratic equations. We just have a few, hot questions to understand. But I thought I'll just stop there because it's anyways for term 2. So I'm starting a new chapter today, coordinate geometry. So quadratic equations and statistics. We have covered these two chapters, which forms a part of term 2 syllabus. So we'll just withdraw from that chapter, quadratic equations, and we'll start this new chapter, coordinate geometry today. My screen is visible. Is my screen visible, children?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
All right, children.
Yes, ma'am.
Yes, children, fine. Fine. So let's understand. So this is coordinate geometry. And here we shall first understand how to find or the formula to find the distance between 2 points, any 2 points in the Cartesian plane. So say there is a point X and another point Y lying in the Cartesian plane. Okay, there's a point X. The address of X is given to you. The address of X is given to you. And you have another point Y. You know the coordinates or the address of Y or the coordinates of Y. So we will be learning this formula, which is called the distance formula, which will help you to find the distance between any 2 points in the Cartesian plane. Say we have 2 points X and Y. To use the formula, you need to know the address of both the points X and Y. You need to know the coordinates of X and the coordinates of Y. So when you know the coordinates of the point X and when you know the coordinates of the point Y, you can connect this. You can connect these 2 points by a straight line. XY is a line segment. When you connect the points X and Y, when you connect these 2 points X and Y, XY is a line segment. It has a definite length. X is a point, Y is a different point. When you connect these 2 points by a straight line, XY is now a line segment. XY is a line segment and it has a definite length. The length of this line segment XY can be found using the distance formula. To use the distance formula, you need to know the coordinates of X and the coordinates of Y. So let's understand. Let's learn how to derive the formula. So you can see here the distance between 2 points A given by the coordinates x1, y1 and B given by the coordinates x2, y2. So the distance between A and B is given by the formula. The distance between 2 points A and B is given by the formula AB. Why AB? Line segment is represented like this. Line segment AB is equal to 7 centimeters. XY is equal to 10 centimeters. So AB, because we are talking about the length of this line segment AB. So the length of this line segment AB or the distance between the 2 points A and B, both mean the same. The distance between the 2 points A and B is the same as the length of the line segment AB. Both are the same. The distance between the 2 points A and B is the same as the length of the line segment AB. So the length of the line segment AB, or the distance between the 2 points A and B, is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So you can see here x1 and x2. You can see here x1 and x2. X1 and x2 are the x coordinates of the points A and B. Y1 and Y2 are the y coordinates of the points A and B. X1 and X2, X1 and X2, children listen carefully. X1 and X2 are the x coordinates of the points A and B. What is the other term used for x coordinate? What is the term? What is the other term that refers to the x coordinate point? Abscissa. Abscissa. So here it is the x1 is the x coordinate of A, and x2 is the x coordinate of B. So we're talking about two x coordinates. So we say abscissae, plural, abscissae, abscissa, abscissae. Abscissa, abscissae. Like we say amoeba, amoebae. Okay. So what do we see here? We see that the x coordinates, this is the difference between the x coordinates. See here x2 minus x1. X2 minus x1. So it is a difference. Children, listen carefully. It's a difference between the x coordinate of B and the x coordinate of A. Difference between the x coordinate of B and the x coordinate of A squared plus difference between the y coordinate of B and the y coordinate of A squared. That's what we see under the square root. But what we understand is, now supposing x2 is 5. Supposing this is 5 and this is 3. 5 minus 3 the whole square is 2 squared 4. 4. What if this is 3 and this is 5? This is 3 and this is 5. 3 minus 5 minus 2 squared plus 4. A minus B the whole square is the same as B minus A the whole square. Children, you may have learned this formula in school. If you have studied this chapter in school, you may have come across this formula. But please, I want to tell you something else. Please listen to me. So what you see here is something like A minus B the whole square. We know that A minus B the whole square is the same as B minus A the whole square. See, when you find the difference and square it, you will get the same value. Just check with some numbers. Just check with some numbers. 10 minus 8 the whole square is 2 square 4. Okay, why 2 always? 10 minus 7. Okay, so 10 minus 7 the whole square is 3 square 9. 7 minus 10 the whole square. 7 minus 10 is minus 3 squared. Minus 3 into minus 3 plus 9. We get the same result in both the cases. 10 minus 7 the whole square is the same as 7 minus 10 the whole square. 10 minus 7 the whole square is the same as, the result is the same as 7 minus 10 the whole square. So x2 minus x1 is squared. See here children, 10 minus 7 is not the same as 7 minus 10. No, 10 minus 7 is not the same as 7 minus 10. But so that means A minus B is not the same as B minus A. No, they're different. But A minus B the whole square is the same as B minus A the whole square. So x2 minus x1 the whole square is the same as x1 minus x2 the whole square. y2 minus y1 the whole square is the same as y1 minus y2 the whole square. You're finding the difference and squaring it. So you can find the difference in any order. You can find the difference in any order. You can write x2 minus x1 the whole square or x1 minus x2 the whole square. The result is the same. Here you can write y2 minus y1 the whole square or y1 minus y2 the whole square. So when we express this formula in words, it is the square root of, it's a square root of, see this one, square root of difference between the abscissae, the whole square, plus difference between the ordinates. Y coordinate is called the ordinate. Y coordinate is called the ordinate. Ordinates. Difference between the ordinates, the whole square. So you just find the difference, any order. You write anybody first. So the distance formula is given by the square root of difference between the abscissae. Difference between the abscissae, the whole square, plus difference between the ordinates, the whole square. Which means you can subtract, you simply have to subtract the x coordinates and square it. Plus subtract the y coordinates and square it. And one more thing is you can write this first and then also this because it's addition. It's addition. You could write this first. You could write y2 minus y1 the whole square plus, okay, square root of. You could write this also first. y2 minus y1 the whole square plus x2 minus x1 the whole square because it's addition, no? So it's okay. We could write this one first and then this. So you can also treat this as square root of difference between ordinates, the whole square, plus difference between abscissae, the whole square. We have 2 points. So we have abscissa here and abscissa here. So abscissae, the difference between these two. Write this first and then this, or this first and then this, any order. Find the difference between these two, square it. Find the difference between, write the difference between these two and square it under the square root and add both. So this is what the formula is. Let's see how we get this formula, how this formula was derived. Let's just see a numerical version so you understand it better. Here, children. Look at this one. Find the distance between the points. Find the distance between the points. See, there are 2 points in the Cartesian plane. How do we know on the Cartesian plane? Because see the address, x coordinate, y coordinate, x coordinate, y coordinate. So these 2 points A and B lie in the Cartesian plane. These 2 points lie in the Cartesian plane. This is the address of A, this is the address of B. Now find the distance between the points A and B, which means you need to find the length of the line segment AB, the length of the line segment AB, or the distance between the 2 points A and B. So see here, these are 2 points. Look at this, children. Look at this straight away. Look at this one. Square root AB is equal to square root of. Please see this line. Square root of x coordinate. This is the x coordinate of A. This is the x coordinate of B. So you can write 7 minus 10 the whole square or 10 minus 7 the whole square. Any way you can write. You can write 7 minus 10 the whole square or 10 minus 7 the whole square plus you can write 13 minus 9. Difference between the ordinates 13 minus 9 or 9 minus 13, any order, 13 minus 9 or 9 minus 13 the whole square. Square root of difference between abscissae, the whole square, plus difference between ordinates, the whole square. Then you know how to simplify. And the length of this line segment AB is 5 units. 5 units. So you don't have to worry if you should call this one x1 and y1 or this one x1 and y1, nothing like that. Don't worry if which should be x1, which should be meaning which point should be called x1, y1, which one should be called x2, y2. Don't worry about that. It's simply the difference squared. Let's see the derivation. So children, so you can see the x-axis, y-axis. These are the 2 points A and B. These are the 2 points A and B. A given by the address x1, y1. B given by the address x2, y2. And you can see here the line segment connecting the points A and B. So we need to derive the formula to find the distance between the 2 points A and B. Okay. Construction, what we do is we drop, see, as of now, we have the x-axis, we have the y-axis, we have the point A and we have the point B. How do we draw this? Now you here on the screen, you see the entire figure. But what is the order? How do you get this? So first draw the x-axis or take the x-axis and then the y-axis. Then mark these 2 points A and B. Mark these 2 points A and B, connect it. Connect the 2 points A and B. Let the address of A be x1, y1 and let the address of B be x2, y2. So now we have the axis, both the axis and the 2 points connected by this line segment x1, y1, x2, y2. After this, we need to drop AL. From A, drop AL. From A, drop or draw AL perpendicular to the x-axis. From B, draw BM perpendicular to the x-axis. Also draw AN perpendicular to BM. Draw AN perpendicular to BM. So AL is perpendicular to the x-axis. BM is perpendicular to the x-axis. That means from the 2 points A and B, we are dropping perpendiculars to the x-axis. Then from A, draw AN perpendicular to BM. Like this, we have a right triangle being formed here. We have a right triangle being formed here, right angle at N, wherein AB is the hypotenuse. ANB is the right triangle at N by construction. So AB is the hypotenuse. This formula is derived using Pythagoras theorem. Because we need to find the length of this line segment AB, which is the hypotenuse of this right triangle. And Pythagoras theorem says AN square plus BN square is equal to AB square. So using Pythagoras theorem, we are going to find the length of the line segment AB in terms of x1, y1, x2, y2. We'll apply Pythagoras theorem in this triangle, and find the length of the line segment AB in terms of x1, y1 and x2, y2. Now to use Pythagoras theorem, you need to know the lengths of the, see, AB we have to find. So we don't have, or since we have to find AB is unknown. We're going to find it. But to use the theorem, you need to know the length of the line segments A and sorry. To use Pythagoras theorem, you need to know the lengths of the line segments AN and BN. AN and BN, the legs of the right triangle. You need to know this length and this length. So let's find AN and BN. We need to have, because otherwise, what will you substitute? What will you substitute? AB, fine, we're going to find. But to use the theorem, you need to know the length of this line segment AN and BN. AN and BN. Children, now tell me, supposing, this point here, all right, this point. Children, listen carefully. Please listen carefully. Supposing, say this is like 10, okay? So this is say 10, 10, 8, okay? This is 10, 8. Please remember, children, I'll forget. Please, so you will help me to recall in case I forget. So this is say 10, 8. So see from here, this is like 10, correct? 10 and it's 8 here. It's 8 here. So 10, 8. We understand that, right? So from here to here, this is 10 units. And here, this is 8. So we have this 10, 8. 10, 8. And this one says something like 3, 4. 3, 4. What is it? 10, 8. This is 10, 8. This is 3, 4. So 3, 4 meaning from here it is 3. This is 3 and this is 4. Correct? This is 4. This is 4. That's why this point. No, I'm taking the address of the points A and B. A and B. A and B. I'm just calling B as 10, 8 and this one as 3, 4. 3, 4. That means it will be 3 from here to here. This is 3 and from here to here this is 4. So 3, 4. Now children, 10, 8, 3, 4. Now how much is OM, children? How much is OM? OM.
10.
How many units? How many units?
10, ma'am.
How many
10,
units?
ma'am.
10 units. That means
10
because
units.
because we said it's 10, 8. So it's 10, right? That means X2. That means X2. See, if this is 10, 8, if this is 10, 8, you say that OM is 10, right? That means X2.
Yes, ma'am.
See, I'm not talking about this point. I'm talking about the length from here, the length from here to here. You have marked like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 here. So from here to here, the length is 10 units. This point, this is marked 10. On the x-axis, this will be marked 10. You'll have divisions 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 here. 10 here. So the length from, okay, the length of the line segment OM is 10 units. The length of the line segment OM is 10 units. It is marked 10 here. And the length of the line segment OM is 10 units. 10 units. Okay. Now, so you all told me that OM is 10, children. You all told me OM is 10, which represents X2. Now, what's the length of the line segment OL, children? OL.
3.
We took this as 3, 4, right? We took this as 3, 4. So this is 1. It will be marked 3 here, right? So OL is 3 units. OL is 3 units. OM is 10 units. See, this is 10, 8. 10 will be marked here. So OM is 10 units. And if this is 3, 4, it will be marked 3 here. 3 here. This is 3. OL is 3 units. Then how much is LM? How much is LM then?
7.
LM 10.
7.
Yeah,
7.
because it's minus 3, 7. So LM is 7. So if LM is 7, AN is also 7 because this is a rectangle. Opposite sides are equal. This is a rectangle. Opposite sides are equal. So OM is 10 units. OL is 3 units. So LM will be OM minus OL. 10 minus 7. Sorry, 10 minus 3 is 7 units. LM is 7 units. So AN is also 7 units. So we found AN. Now tell me in terms of X2 and X1, children. You said this was 10, so X2, and this was 3, X1. So from here to here, OM is X2 units. OL is X1 units. So LM will be X2 minus X1 units. See, you all said OM is 10. 10 means X2. And you all said OL is 3, which is X1. 10 minus 3, X2 minus X1 will be X2 minus X1 units is the length of LM. So if LM is X2 minus X1 units, then AN is also X2 minus X1 units. Is it fine, children? Do we understand
Yes,
that?
ma'am.
It's like a rectangle, ma'am.
Yes. It's not like a rectangle. By construction, no, we've brought perpendiculars. So then this figure is a rectangle. This is 90 degrees, this is 90 degrees, this is 90 degrees. So this is also 90. Opposite sides equal. LM is equal to AN. All right. Now, children, tell me, how do we find BN? How do we find BN? Tell me that. We need
X2 minus.
Ma'am, y2 minus
no,
y1.
one minute. Please answer this question. No. Which are the two line segments which we need to subtract to get Bn? Which line segment minus which line segment to get Bn?
BM minus NM.
BM minus NM.
Bm minus Nm. Perfect. Bm minus Mn. This one. Bm. This full
Minus
thing.
NM.
Minus Nm will give us Bn. Will give us this Bn. Now, children, so see the marking here. This is Y2, no? This Y2 is here. It's marked here. This is Y2. This length. This one is Y2. This one is Y2. So this is Y2. And this, okay, we call this how much? We call this how much? 10, 8, I think. 10, 8 and 3, 4.
8,
Yeah.
8.
Yeah. So if 10, 8, that means this is 8 units. The length here is 8 units. This one, because here it's 8, no, this is 8. So correspondingly, this will be 8 units. 3, 4. That means this is 4 units. AL is 4 units. AL is 4 units. Please understand this. This is 3, 4. 3, 4. It's 3 here and 4 like this. This is 4. This is 4. This is Y1. This is X1. This is X1. This is X1. This is Y1. AL is Y1. See this X1, Y1. X1 is OL. OL is X1. And Y1 is AL. This is Y1. This is Y1. Similarly, when you take this, when you take the point B and its coordinates, X2 is OM. This is X2. And Y2 is this one, BM. This is Y2. So clearly, Y2, that is BM minus NM, but NM is equal to AL. NM is equal to AL. Opposite sides are equal in a rectangle. So if this is Y1, this is also Y1. So Y2 minus Y1 units is the length of this side BN. BN is equal to Y2 minus, because this is Y1, this also will be Y1. Y2 minus Y1 units, which means AN is X2 minus X1 units and BN is Y2 minus Y1 units. You can see this later. That's what is worked here. So now use Pythagoras theorem. Having found AN and BN, you should know, see, like what to find. How do you know what to find? So you should understand that we're using Pythagoras theorem. We are using Pythagoras theorem to find the length of the line segment AB, which means you need to know the lengths of AN and BN. So that is the arrangement. Preparation. Before you use Pythagoras theorem, we are preparing. We find AN, we find BN. Now, by applying Pythagoras theorem, we have AB square is equal to AN square plus BN square. We just found AN is, you can see it here, X2 minus X1, and BN here, Y2 minus Y1. So this is Pythagoras theorem. Now we're substituting. AB square is equal to, we substitute. So AB square is this. AB square is this one. AB is equal to square root of X2 minus X1 the whole square plus Y2 minus Y1 the whole square. So this is how we derive. The distance formula. So it is simply the square root of the distance, the difference between the abscissae, the whole square, plus the difference between the ordinates, the whole square. Now, if you have to find the distance of a point from the origin, if you have to find the distance of a point from the origin, so say P is given by X comma Y, and origin represented by the letter O given by the coordinates 0, 0. Origin O, coordinates 0, 0. So children, what should you do? Subtract the X coordinates. X minus 0 the whole square, plus subtract the Y coordinates, Y minus 0 the whole square. So OP OP or PO, both are the same. OP or PO is equal to square root of difference between the abscissa, x minus 0 or 0 minus x. X minus 0 the whole square plus y minus 0 or 0 minus y, anything, the whole square. Subtract the x coordinates, square it. Subtract the y coordinates, square it. So x minus 0 is nothing but x square plus y minus 0 is y square. So the distance of any point from the origin is given by square root of x square plus y square. Now supposing you have a point P given by the address 3, 4. Supposing you have a point P given by the address 3, 4. You wish to find its distance from the origin. Square root of 3 square plus 4 square. Root of x square plus y square. Here P is P is given by x, y. And see here it is whatever, this is the origin 0, 0. But see the result, it's in terms of x, y, which are the coordinates of the point P. The distance of this point P from the origin is given by root of x square plus y square. That means this one, x square plus y square. So we have the point P given by the address 3, 4. So square root of 3 square plus 4 square, 9 plus 16, square root of 25, 5 units. So the point P given by the address 3, 4 is located at a distance of 5 units from the origin. So supposing we have a point A given by the address 4, 4. A given by the address 4, 4. The distance of this point A from the origin will be square root of 4 square plus 4 square. Square root of 4 square plus 4 square. 16 plus 16. Root 32, which is 4 root 2 units. Root 32, which is 4 root 2 units. So this is how we find the distance of any point from the origin. These are the two things. Take a screenshot, children. Yeah, please take a screenshot. Complete this in your book. Not now. Work it as homework. Any doubts, children? Any clarifications?
No, ma'am.
Got the derivation clearly, children? Can we move on?
Yes, ma'am.
Yes,
All
ma'am.
right. All right. So here you see the summary of what we understood. Read this yourself. Read the summary. All right. So see the first one. Find the distance between the points. Find the distance between the points A 7, 13 and B 10, 9. So how do we express the distance between these 2 points A and B? Like this, AB, which is the length of the line segment. Length of the line segment AB is written like this, AB. Also represents the distance between the 2 points A and B. This is the formula. So you can, so square root of, you can write 7 minus 10 the whole square or 10 minus 7 the whole square plus 13 minus 9 the whole square or 9 minus 13 the whole square. Either ways, you will get the same result. So the distance between these 2 points is 5 units. Go through the next one. Please understand example 2. You don't have to write all this, children. You don't have to write x1, xy1. You don't have to write all this. Straight away write. You don't have to write this. The first 2 lines of the solution you don't have to write. Straight away write PQ is equal to the formula and substitute. 1, 2, 3. You don't have to write the first 2 steps.
Ma'am, we should write it now.
No, children. Please, I'll allow you to take a screenshot of the full page. You can complete it later. Not during the class now. Okay. Now tell me, I hope 1 and 2 is fine. Look at the third one. Find the distance of the point P given by 6, minus 6 from the origin. You can use the same formula. You will get the same answer, but quicker. Use this one and get it quicker. Fast. What's the distance from the origin? Root of?
Root of 72, ma'am.
Root of 72. Root 72. Which is nothing but? As a third?
Six root 2, ma'am.
6 root 2. 6 root 2. So root of 6 square plus minus 6 the whole square. So 36 plus 36. When you have 36 plus 36, you know, now, for example, say, okay, fine. So if we have square root of 36 plus 36, right? You know 36 is a perfect square. So don't add 36 and 36. Instead, you treat it as square root of 2 into 36. 36 plus 36, right? You have square root of 36 plus 36. Now 36 plus 36, don't add. 36 plus 36 is 2 into 36. So square root of 2 into 36. Now 36 will come out as 6. So 6 root 2. 2 will remain under the square root. So 6 root 2. You can save time, that's all. Otherwise, if you feel both are easy, fine. When you have to add, when you know the number is a perfect square, like say 400, say it is square root of 400 plus 400. Supposing square root of 400 plus 400. So square root of 400 plus 400, you should write it as square root of 2 into 400. Square root of 2 into 400. So now 400 will come out of the square root of 20. 400 will come out of the square root as 20. So 20 root 2. 2 will remain under the square root. So 20 root 2. Okay. Yeah, this is what I was telling. So you don't have to write root 72 also. Don't write this. What is 36 plus 36? 2 into 36. Straight away, don't write this. Don't write this. 36 plus 36 is 2 into 36. And 36 comes out as 6. 6 root 2 units. Children, we'll be using this extensively. So just have a look at this. See, when we say AB is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, what is AB square without the square root? Supposing you write AB square instead of AB, if you want to write AB square, then don't write the square root here. Please look at these two. AB square is simply x2 minus x1 the whole square plus y2 minus y1 the whole square. AB square means simply x2 minus x1 the whole square plus y2 minus y1 the whole square. AB is square root of this one. So sometimes we may be taking AB square, PQ square and stuff like that. So then don't use the square root symbol, that's all. Class, use the emoji. Raise your hands. Okay. Shriya, Aksharam, Priyadarshini, Priya, Ravya, Shruti, Hariharan, Nafi, Manasa, Lakshita, Shabarigrish, Shakti, Parkavi, Sudarshan, Reshmika, Tirunesh, Nivedita, Muttuvel, Balaharish, and Arnav. So some of them are missing today also. See? I think I did not read Anish and did I read Anish? No. I didn't read Ashwin also. Okay. Okay. All those who are in the meeting are perfectly attentive. Thank you, children. Very good. All right, children. Thank you. See the next one. All right. So see here, example 4. Look at example 4. Find the values of y for which the distance between the points is 10 units. So here you're given the distance between the 2 points. You have to find y, which is the y coordinate or the ordinate of the point B. You have to find y. See, A is a point given by 3, minus 1. B is another point given by 11, y. You don't know the ordinate of B. You know that the distance between A and B, AB is 10 units, that you know. So given AB is 10 units, you need to find y. So see here, children, AB is 10. Why AB is 10? Because the length of the line segment AB is given as 10. If AB is 10, AB square is 100. So what did I tell you? If you have to write, see now this is the equation, children. This is the equation. AB square is equal to 100 is the equation. Now what is AB square? I said don't write the square root symbol. AB square will be, you can write 3 minus 11 or 11 minus 3. So 11 minus 3 the whole square as you see here plus, you can write this minus this or this minus this. So y minus 1. See here, you should subtract these two. Just because there's a minus sign here doesn't mean you can ignore the minus sign which you have to write. This one and this one you should subtract. So y minus 1. So y plus 1 the whole square. Children, simple. This is the first thing. AB is equal to 10 units. Under that you write AB square is equal to 100. AB square is equal to 100. Squaring both the sides. AB square is 100. Now how do you write AB square? How do you write AB square? I just showed you. AB square. Without the square root. You need to show only this. That's what you see here. Without the square root. See here, AB square. For AB square is what you see here. 11 minus 3 the whole square plus y minus 1. So y plus 1 the whole square. This is the distance formula, children. This is the distance formula. The square root is not shown because we are writing AB square and not AB is equal to 100. See, we're just working with this condition. AB square is equal to 100. We know that. Now, what is AB square? This one is equal to 100. I hope we understand. If you write it one below the other, it will be fine. AB is equal to 10. Below that, you write AB square is equal to 100. Below that, for AB square, we write this. This is AB square is equal to 100. Now you know how to solve this. You know how to solve. You can do the solve it now, children, roughly. Please solve it now. All of you solve and tell me the values of y.
5, ma'am.
Y, yeah, y.
No, ma'am, I'm saying it's 5.
Oh, you're saying it's 5.
Y equal to 5.
Okay,
Y
sorry.
equal to 5 or minus 7, ma'am.
Yeah, that's fine. Yes. Might have worked in a different way, children. Don't worry about that. The answer is right.
What's the y value, man?
Yeah. So you can see 11 minus 3 is 8 squared plus y plus 1 the whole square is equal to 100. Here they have not expanded this one. I'll tell you how it's worked here. Normally we tend to expand. It's not expanded here. So y plus 1 the whole square is equal to 100 minus 64, which is 36. So it's like this. Y plus 1 the whole square is equal to 36. Y plus 1 is equal to square root of 36. Y plus 1 the whole square is equal to 36. Y plus 1 the whole square is equal to 36. Y plus 1 is equal to square root of 36. So y plus 1 is equal to plus or minus 6. Y plus 1 is equal to plus or minus 6. So work once with plus 6, work once with minus 6. So when y plus 1 is equal to 6, y plus 1 is equal to 6, we get y is equal to 6 minus 1, 5. Or when y plus 1 is equal to minus 6, we get y is equal to minus 6 minus 1, minus 7. So the two values of y are 5 and minus 7. So this point can be, this point B can be 11, 5 or 11, minus 7. In both the cases, the distance between these 2 points A and B will be 10 units. This point B can be 11, 5 or 11, minus 7. The location will be different. When it's 11, 5, it will be in the first quadrant. When it's 11, minus 7, it will be in the which quadrant? Fourth quadrant. When it's 11, minus 7, it will be in the fourth quadrant. The location of B will be different. However, the distance between A and B will remain 10 units. Children, is it clear?
Yes, ma'am.
Yeah, children, see, you can also expand that. Y plus 1 the whole square, you can expand. You will get a quadratic equation in Y. You will get a quadratic equation in Y. You split the middle term and you will get Y5 and or Y minus 7. You can also expand Y plus 1 the whole square. You will get a quadratic equation in Y. You split the middle term and find the two values of Y. It's not that you should work it as Y plus 1 the whole square is equal to 36. Not like that. This is fine. The other method is also fine. Just a minute, children. Have you all finished? Example 4?
Yes, ma'am.
All right. All right, children. See the next one. If the point P given by K minus 1, 2 is equidistant from the points A, 3, K and B, K, 5, find the values of K. So it's given that P is equidistant. That is, it's at equal distances. The distance from P to A is the same as the distance from P to B. The point P is equidistant from A and B means the point P, the distance of P from A is the same as the distance of P from B, which means PA is equal to PB. Distance PA is equal to distance PB. That means PA square, squaring both the sides, PA square is equal to PB square. PA is equal to PB or PA square is equal to PB square, squaring both the sides. So PA is nothing but, you should write the distance formula for that. PA square, length of the line segment PA, distance formula without the square root, PA square and PB square. So it's here, children. PA is equal to PB because the distance from P to A is the same as the distance from P to B. It's given to us, which means PA square is equal to PB square. Now, how do we write PA square? Be very careful with the signs, children. PA square. So this is P. See, this is P. Please watch. This is P. This is A. So let us subtract the x coordinates. K minus 1 minus 3 the whole square. Subtract the x coordinates. K minus 1 minus 3 the whole square. See, this we are writing for PA square, children. LHS is PA square. RHS is PB square. LHS is PA square, RHS is PB square. So we are writing PA, the formula PA square, P, K minus 1, x coordinate, K minus 1 minus 3, the whole square, plus difference between the y coordinates, 2 minus K, the whole square, is equal to, how do we find PB? I hope you are not writing, you are listening to me. PB square. So take the points P and B. P and B. K minus 1 minus K the whole square. K minus 1 minus K the whole square. Plus, you can write 2 minus 5 the whole square or 5 minus 2 the whole square. Anyways, the whole square. Solve this, children. Solve this. See, you get a quadratic equation. And these are the two values for K. Please work it, children. Just check if you're able to work it correctly. Any doubts, children?
No, ma'am.
Ma'am, how did K minus 1 minus 3 the whole square come? Can you please repeat?
Yes, Arna? Yes, Arna, what's your doubt?
Ma'am, how did K minus 1 minus 3 the whole square come? Can you please repeat?
Yeah, definitely. So what is the formula? What is the distance formula?
Ma'am, root of x2 square minus x1 square plus y2 square minus y1 square. No, ma'am. X2 minus x1 the whole square plus y2 minus y1 the whole square.
Okay. X2 minus x1 the whole square, right?
Yes, ma'am.
No.
Root, under the root.
Yeah. So that is for the distance form. That is AB. AB square. No, now is my voice reaching you clearly, Arna?
Yes,
You
ma'am.
Sure?
Yes,
Okay.
ma'am.
Okay, no issues. Can you just recall what I mentioned here?
AB square is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square, and then the square is, when it comes on the opposite side, it becomes the root.
Okay, so we understand that AB square is like this, right? AB square.
Yes, ma'am.
Okay, remember this, just keep this in your mind. Now, The 2 points are P and A. The 2 points are P and A. PA square. How do you write PA square? Like you saw something there for AB square. How do you express PA square? PA square will be K minus 1 minus 3. The difference between the x coordinates. K minus 1 minus 3 the whole square. Plus the difference between the y coordinates. 2 minus K or K minus 2 the whole square.
Okay, ma'am.
No, I don't know if you're convinced. No, 1 minute.
Still, I didn't get it, ma'am.
I'm not clear, right?
I didn't understand much, ma'am.
Okay. Fine. What about these examples, Arna? What about these examples?
Others I understood, ma'am.
Okay.
That substitution, how PA square, that how did you substitute K minus 1 minus 3? That I didn't get clearly.
Okay, so fine. We understand PA is equal to PB?
Yes, ma'am, because they
Okay. Yeah, then how do I write PA square is equal to PB square? By squaring both the sides. Is that fine?
Yes, ma'am.
Okay, now PA square. So for that we need to come. PA square is that like that AB square there. PA square, the distance between P and A. This is the x coordinate of P, K minus 1. And 3 is the x coordinate of A. The difference between them should be squared by the according to the formula. K minus 1 minus 3 the whole square. According to the formula, x2 minus x1 the whole square.
Okay, ma'am. Understood.
Plus, according to the formula, the difference between the y coordinates, 2 minus k or k minus 2 the whole square. x2 minus x1 the whole square plus y2 minus y1 the whole square. For PA square is equal to PB square. For that, take the points P and B. P and B. Take the points P and B. So k minus 1 is the x coordinate here. K is the x coordinate here. So k minus 1 minus k the whole square. Plus 2 is the y coordinate. 5 is the y coordinate. So 2 minus 5 the whole square. First we write PA is equal to PB. Then below that we write PA square is equal to PB square. So for PA square, this is the expansion. For PB square, this is the expansion.
Okay, ma'am. Got it.
All right, Arna. Yeah.
That time I didn't get the values of x1 and y1 properly. That's why I couldn't.
No, Arnav, I see it's like this. You can write, I told you, no, in words, it is the difference between the abscissa, the whole squared. You can subtract the x coordinates in any order and square it. These are the 2 points. P and A are the 2 points. Look at the x coordinates, k minus 1 and 3. Subtract them in any order. You can write 3 first and then k minus 1 or k minus 1 first and then 3. You just need to subtract them and square it. Any order. Nothing like this only should be x1, y1 and this should be x2, y2. You can take this as x1, y1 and this as x2, y2.
Yes, ma'am. Clear.
It's simply like this. Subtract the x coordinate, square it. Subtract the y coordinate, square it. And add the results. Add both.
Got it.
All right. Are we able to solve this, children? All of you? Are you able to solve this and get these values?
Yes,
K1,
ma'am.
5, K1 or K5?
Yes, ma'am.
Okay.
Ma'am,
Yes.
ma'am, I'm in doubt.
Yes, Shakti.
Ma'am, PA means you want to take as K minus 1, comma 2 into 3, comma K.
No, PA means, come again.
We want to take as K minus 1, comma 2 into 3, comma K only. Ma'am. I cannot understand this step.
Which step? This one, huh? The first step
Yes.
here.
Yes, ma'am.
No, can somebody else tell me this first step? Anyone who thinks has understood? How do we write this first step?
Ma'am, we take the values of P and PB. And here, for example, for PA side, we take x1 as k minus 1. We can take other also, but here, just for example, we are taking x1 as k minus 1 and x2 as 3.
Okay.
And y1
Yes.
as 2 and y2 as k.
Okay.
And then the formula is there in the derivation that ab square is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square.
Yeah.
So we square on both the sides, and then since PA square is equal to PB square, we put that as an equation and then we solve by substituting the values.
Yeah. You're right, Arya. Happy that you understood. No, Shakti, that was Shakti, right? Yes. No, Shakti, I don't know. Meaning, where the doubt is. It's just substituting in the
Now I
formula.
understood.
No, Shakti. See, if it is not clear, we have to sort it out. No. Wait. What was the doubt actually? Do we understand the formula?
Ma'am, yes, ma'am, I understood the formula.
Okay. Okay, now tell next one you're going to tell me then. If you feel you understood example 5, we are going to do example 6 together. All right. In example 6, find the relation between x and y. Find the relation between x and y such that p x comma y is equidistant from a and b. So this point P is equidistant from A and B. That means PA is equal to PB or PA square is equal to PB square. This point P is equidistant from A and B. That means the distance from P to A is the same as the distance from P to B, which means PA is equal to PB. PA is equal to PB, which means PA is equal to PB, which also means PA square is equal to PB square. Squaring both the sides, PA square is equal to PB square. Yes, Shakti, tell me, what will you write under PA square? Now we have in the LHS, we have PA square. In the RHS, we have PB square. Now, how do you continue? What is PA square? What will you write for PA square, Shakti?
X minus 1.
X minus 1.
I'm 1 meter. Yes, ma'am, x minus 1 is equal to y plus 1. Is it right now?
No.
Ma'am, shall I tell?
No, 1 minute. He knows it. He'll say. We'll just wait. Yes, Shakti, please. What's the formula,
Yes,
Shakti? What is AB square formula? Look at this formula.
AB is equal to root of x2 minus x1 plus
See this
y2
one.
minus.
This one. See this one. AB square is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square.
Yes, ma'am.
Okay. Have you got this?
Yes,
Now
ma'am.
apply this here. Now PA square. So look at the points P and A. P and A. What is the x coordinate of P?
It is x, ma'am.
And the x coordinate of A?
1, ma'am.
Subtract them.
X minus 1 the whole square.
Plus. What are the y coordinates of P and A?
Y minus 4 the whole square.
Y minus 4 the whole square. That is the complete formula.
Okay.
You are like, yeah, you're like subtracting. Okay, that's the complete formula. PA square is x minus 1 the whole square plus y minus 4 the whole square. Now tell me PB square.
It is x plus 1 the whole square. Then y minus 2 the whole square.
Yeah, connecting sign.
Minus.
No, x2 minus x1 the whole square. You said y2
Plus.
minus y1. Huh?
Plus, ma'am.
Plus.
Yes, ma'am.
So x minus 1 the whole square plus y. Sorry, no, this is PB, right? Okay. X plus 1 the whole square plus y minus 2 the whole square.
Yes, ma'am.
You sure you got it? Okay.
Yes.
Okay, fine. Solve that, children, all of you. All of you solve that. So the difference between example 5 and 6 is that in example 5, there was only one unknown k. There was only one unknown k. So on solving, you were able to find the values of k. But in example 6, we have two unknowns x and y, but you have only one condition. So you cannot find x and y. You can only find a relation. Like you will get something like 3x minus 4y is equal to 7. You will get a linear equation in x and y. Something like that. maybe x plus y is equal to minus 5. You will get a linear equation in x and y. That is why find the relation between x and y. You cannot find the values of x and y because there's only one condition, and with one condition you cannot find two unknowns, x and y. So you will only get a relation. You will get a linear equation in x and y. What is the linear equation you got? Please put it in the standard form and tell me. Like for example, 2x minus 3y plus 7 is equal to 0. Tell me like that. What's the equation?
Ma'am, x plus y
Yes.
equal x plus y minus 3 equal to 0, ma'am.
X plus y minus 3 is equal to 0. Okay, let's check Parkavi. Where are the others? Srinivasan had texted me that he will not be able to attend today. So he's not there. Thirunesh, you were answering earlier in some classes. Now again, back to silent mode.
Minus x minus y plus 3 is equal to 0.
Oh, looks like what Parkavi has got. Change the signs throughout. Let's not have a minus x. Let's not start with a negative sign. So change the signs throughout. So I think you get x.
Y minus 3, ma'am.
Yeah, let's see. X plus y minus 3 is equal to 0. Let's see. Yeah, you leave it like this, children. So not like this. Leave it like x plus y minus 3 is equal to 0. I think Parkavi and Shakti, both of you have got it right. Others? X plus y minus 3 is equal to 0. Leave it in the standard form. X plus y minus 3 is equal to 0. Just bring everything to one side. X square, y square on either sides will get cancelled. When you're expanding, you should be careful. A minus b the whole square is a square, b square, 2ab. Don't forget the 2ab. When you expand this, you will get 3 terms. 3 terms. So 3 plus 3, 6 terms you will have in the LHS. And here also 3 plus 3, 6 terms in the RHS. You'll have 6 terms in the LHS and RHS. X square, y square gets cancelled. Then you have 3 terms here, 3 terms here. Bring all the terms to one side.
Ma'am,
Yes.
in the question, is there a printing mistake in the solution?
Oh, I don't know that. You have to tell me.
Because here they have given PA square is equal to PB square. Shouldn't it be PA the whole square, the bracket?
Oh, no. PA is one thing. So PA is one thing. So it need not be PA the whole square. PA square is the same as PA the whole square because P and A are not independent there. PA is one thing. PA is the line segment. So PA square is fine.
Okay, ma'am.
See, if it is XY, where X and Y are different, XY is X into Y, but PA is not P into A. When we write XY, the small letter X and Y, when we write XY, that means X into Y. When it is X into Y and you're squaring it, you must write XY the whole square. But here PA square is not P into A. PA is one thing. So this is fine.
Okay, ma'am.
Yeah. Are we all getting the equation right? No, I meant that one. The final answer, if there's a printing mistake, only you have to tell me. Are we all getting this? X plus y minus 3 is equal to 0, children?
I got that minus x minus y plus 3. After that,
Yeah.
I changed.
Correct, correct. When you change the signs throughout, you get, yeah, that's right. You're getting it. Okay. Children, see, there's no point proceeding if you have doubts here. If you're not still not clear in applying the distance formula, tell me. I'll repeat it. It's a very simple chapter. You just have to use a formula everywhere. Or maybe if you feel you need to help yourself, then before tomorrow's class, I'll share the recording. Listen to the introduction again. You should not have any doubt in using the formula. Okay, so in example 5, there was only one unknown, k. So with the given condition, we were able to find the values of k. While in example 6, we have two unknowns x and y, but you have only one condition. So you cannot find x and y, but you can find the relation between x and y. X plus y minus 3 is equal to 0. Okay. Now, answer this, children. How will a point on the x-axis look like? What are the coordinates? How will you generalize? How will you generalize the coordinates of a point on the x-axis?
Ma'am, the point of x and the y is 0. The
So
value
x
of y
comma
is
0.
0.
Correct, correct. X comma 0.
Yes,
X comma 0. Yeah. So in general, any point lying on the x-axis, okay, it can be minus x comma 0 also. So fine. So x comma 0. X can be a negative value also. X can be a negative value also. X can be negative or positive. Can be minus 3 comma 0 or 3 comma 0. Okay, so in general, a point lying on the x-axis will look like x comma 0. And on the y-axis?
0, comma y.
0 comma y. 0 comma y. Now answer this question. Yes. Please work example 7. Find those points on the x-axis, but you assume one point. You can just start like let B be a point on the x-axis. Let B be a point on the x-axis. So B will have the address x comma 0. Try. Let's see what you can do with it. Yes, I hope something is happening.
In 1 week, can you explain the question?
Ma'am, the points are 1 and 9.
1 and 1?
9.
1 comma 9, is it? Oh, not 1 comma 9. Sorry. What is that? 1 and 9.
1 comma 0 or 9 comma 0, ma'am.
0. Very good. Yeah, 1 comma 0 or 9 comma 0. Okay, let's see. Let's see. Okay. Now we need to find a point on the x-axis. So let that point on the x-axis be P or any letter you can use. So here they've used P. So let me say P. And you know that every point on the x-axis looks like x comma 0. If a point lies on the x-axis, then it will be of the form x comma 0, some x value comma 0. So now there is this point P on the x-axis with the address x comma 0. There is another point A whose address is 5 comma minus 3. AB is given to be 5 units. AB, the distance between A and P, AP is equal to 5 is given. AP is equal to 5. That means AP square is equal to 25. AP is equal to 5 because the distance between A and P, A is 5 comma 3, P is x comma 0. AP is equal to 5. AP square is equal to 25. And how do we write AP square, Shakti? How do we write AP square?
25.
AP square is equal to 25. Now for AP square, what will you expand? For AP square. The formula.
AP square is equal to x2 minus x1 the whole square plus y2 minus 1. That is
Correct. Yeah, now use the values and tell me. P is x comma 0. So how will it work? X2 minus x1 the whole square. What is it?
X minus 5 the whole square.
X minus 5 the whole square plus
Plus 0 plus 3 the whole square.
0 plus 3 the whole square. Very good. X minus 5 the whole square plus 0 plus 3 the whole square is equal to 25. Is equal to 25. AP square is equal to 25. AP is equal to 5. AP square is equal to 25. And AP square, you should use a distance formula, is equal to 25. Solve that equation. See here. Let the required point P. Let the required point on the x-axis be P x comma 0. So the distance between P and A, PA is 5. That means PA square is 25. Now how do you write out PA square? Using the formula x2 minus x1 the whole square plus y2 minus y1 the whole square is equal to 25. PA square is this one by the formula is equal to 25. Solve this equation and find the values of x. So on solving, x is equal to 1 or 9. So the required points are 1 comma 0 because the point is x comma 0, right? So the points can be 1 comma 0 or 9 comma 0. It can be 1 comma 0. You don't have to mention B and C here. You can say the point P. The point P can be given by the address 1 comma 0 or 9 comma 0. In solving children, be careful. Expand this using a minus b the whole square. 0 plus 3 is 3, 3 square is 9. Expand this using a minus b the whole square. All of you getting 1 and 9?
Yes, ma'am.
1 or 9.
Yes,
1 or 9. Okay, so that means x can be 1 or 9. So if x is 1, the point is 1, 0. If it is 9, 9, 0. So the point P can be 1, 0 or 9, 0. This was x-axis. See here, find those points on the y-axis, each of which is equal, find those points on the y-axis, each of which is at a distance of 13 units from the point A minus 5, 7. So here you know one point A given by minus 5, 7. You need to find, there is more than one point, but you don't have to assume, you assume only one point. You will get, if there are 2 or more points, you will get the addresses just by assuming one point like this, because you will get 2 values for y. So one point is given minus 5, 7. Let that other point be P. Why did we take the 0, y? Because it's given, find those points on the y-axis. If the points lie on the y-axis, it will be of the form 0, y. So one point is minus 5, 7. The other point is P 0, y because it lies on the y-axis. Now the distance between these two is 13. The distance between these two is 13. AP is equal to 13 or PA is equal to 13. That means PA square is 169. And how do we write PA square? Difference between these two x coordinates, 0 plus 5 the whole square plus y minus 7 the whole square or 7 minus y the whole square is equal to 169. Solve this equation and find the values of y. So this point P can be 19, 0 or minus 5, 0. Children, I'm just waiting for you to check if you're able to work this, correctly and get the same values, 19 and minus 5.
Is it 19 and minus 5, ma'am?
Yes, 19 and minus 5. So the point can be 19, 0, 19 or 0, minus 5. Look at the next one. Find the point on x-axis which is equidistant from the points 5, minus 2 and minus 3, 2. Please understand the question carefully. Find the point. You need to find a point on the x-axis. So if it is on the x-axis, it will be like x, 0. It's on the x-axis, so it's x, 0. Find the point on the x-axis. So x comma 0. This point, supposing we call it P, Px comma 0. Supposing we call it Px comma 0. Find the point on the x-axis. So Px comma 0. Now this point P is equidistant from, we'll call this A and B. You can see it here. They've given it here. A and B. Let's call this A and let's call this B. So that means P is equidistant from A and B. That means PA is equal to PB. That means PA is equal to PB. See, it's given here. Find the point on the x-axis. That point is equidistant from A and B. The distance from P to A is the same as the distance from P to B. The distance from P to A is the same as the distance from P to B. So PA is equal to PB and P is given by x comma 0 because it lies on the x-axis. So it's given by x comma 0. So there is a point P on the x-axis x comma 0 and we have these 2 points given to us A and B. Now the condition given is PA is equal to PB. The distance from P to A is the same as the distance from P to B. So PA is equal to PB. PA square is equal to PB square. Work it, children. Work and tell me the answer.
Ma'am, x is equal to 1.
X is equal to 1. Okay. X is 1. Oh, you're right. X is 1. Good, Tirunesh. X is 1. You're right.
Ma'am, is x is equal to minus 1.
No, somebody said 1, not minus 1. It's on minus 1.
Yes, ma'am, I got 1.
Very good. So since we have to find a point on the x-axis, we call it x comma 0. Let P be given by x comma 0. There are 2 other points, we'll call them A and B. What is given? This point P is equidistant from A and B. So PA is equal to PB or PA square is equal to PB square. Use the formula and fill up PA square. PA square is this one, x2 minus x1 whole square plus y2 minus y1 whole square is equal to PB square. Same thing. Use the points P and B and write out using the formula and work this. Solve this. See, you don't have to use this method here, children. You just expand and do it in your own way. You must get x is equal to 1. That's what it is. So when if x is 1, that point on the x-axis is 1, 0. That point, the required point on the x-axis is 1, 0. Try the next one. Example 10. What will you call that point on the y-axis?
I'm doing
0,
ma'am.
No, but how do you, in general, assume
0,
a point on the 0, y. 0, y. And it's given that this point 0, y is equidistant from the two other points. Similar to example 9, children.
Ma'am, is y minus 7?
Yeah, 1 second. Minus 7, is it?
Yes.
Let's check. Yeah, you're right. Y is minus 7. Y is minus 7.
You see, y is equal to minus 20, ma'am.
No.
Y is equal to -7.
Yes, y is -7. Please check your steps. Okay, so maybe you not work like this, but 0 plus 5, the whole square is 25, and this will expand to y square minus 4y plus 4. Expand it carefully. Bring all the terms to one side. Yeah. Y is equal to -7. Y is -7. How many of you got y -7? Yeah, tell me your name.
Ma'am, I have got one. Harkavi, ma'am.
Parkavi got it. All right.
Arnav, ma'am.
Tiranish, ma'am.
Iranesh, good.
Reshmika, ma'am.
Reshmika, good. Okay. Let's continue with example 11 tomorrow. Oh, but did I allow you to take a screenshot, children? Those who need to take a picture, please do it now. Just wait for about 5 seconds with every slide. Those who need to take a picture, please take.
Done, ma'am.
Yeah. Yes, we'll try these simple ones. How do you prove that tan square theta minus, see this is the heading, children. This is the heading. Prove the trigonometric identities. Prove this one. Tan square theta minus 1 by cos square theta is minus 1. So we will take up the LHS. Tan square theta minus 1 by cos square
And we
theta.
can
What will
write
be the next
tan
step?
square theta as sin square theta by cos square theta.
Okay.
And we can take the LCM, ma'am, so we can get sin square theta minus 1 by cos square theta is equal to, ma'am.
Okay.
Sin square theta minus 1 is cos square theta, ma'am. So 1 by 1 is equal to 1.
No, sin square theta minus 1 is not cos square theta. What is sin square theta minus 1?
Ma'am, 1 minus sin square theta is equal to cos theta. Cos square theta.
Okay, but what is sin square theta minus 1? Because we have that to the numerator. What is sin square theta minus 1?
Minus cos square theta.
Minus square theta, ma'am.
Minus cos square theta. So
Yes, ma'am.
minus cos square theta by cos square theta, which is 1, minus 1. Correct.
Yes,
You're right, Shakti. Very good. What about the next one? Cot square theta minus 1 by sin square theta is minus 1.
ma'am. We can write as cos square theta by sin square theta, ma'am.
Okay.
So cos square theta minus 1 is minus sin square theta, ma'am. So we'll get minus 1.
Very good. You can do it that way, or I think I've done it in a different way. See here. Tan square theta, this is the LHS, tan square theta minus 1 by cos square theta. What Shakti explained is also fine. Perfect. You can also do it like that. Be careful, sin square theta minus 1 is minus cos square theta. Sin square theta minus 1 is minus cos square theta. We should be careful there. Okay, so see the results here. Tan square theta minus 1 by cos square theta secant square theta. Tan square theta minus secant square theta can be written as minus of secant square theta minus tan square theta. Recall that. See here, minus secant square theta, minus into minus plus tan square theta. Minus secant square theta, minus into minus plus tan square theta. If you want to write, this as a minus b as b minus a, you must take a minus outside. You want to write tan square theta minus secant square theta in the other way. Secant square theta minus tan square theta, then take a minus outside. And now we know that secant square theta minus tan square theta is 1. This is 1, so minus 1. Same thing here. Yeah, tell me the fourth one. We'll wind up with this one. What is root of 1 minus cos square theta?
Sin square, root sin square theta.
Root sin square theta. Yes, root sin square theta. And what is root sin square theta?
Sin theta.
Sin theta, ma'am.
So what do you have? Cosecant theta into sin theta.
Which will be 1, ma'am.
How?
Because cosecant theta is 1 by sin theta, ma'am. So 1 by sin theta into sin theta is 1.
Very good. Cosecant theta into 1 by sin theta, so it's 1. Very good. What about the third one?
Now we can write the tan square theta as sin square theta by cos square theta.
Very good. Next.
And sin square theta is equal to the cos square theta and cos square theta will cancel, ma'am. So 1 minus cos square theta is sin square theta, ma'am. So both will be equal.
Very good. Very good. Good, Shakti. Yes. So tan square theta, sin square theta by cos square theta into cos square theta. Cos square theta cancels out. So sin square theta. But the RHS is not sin square theta, it's different. But we know that sin square theta is 1 minus cos square theta. Sin square theta is nothing but 1 minus cos square theta, which is the RHS. Here, cosecant is 1 by sine. 1 root of 1 minus cos square theta, sin square theta. Root of sin square theta, sin theta. Cancels 1, which is the RHS. All right, children. So that's it for today's session. We'll continue with the coordinate geometry tomorrow. Please go through and come prepared for the class. If you have any questions, please stay back, children. Else you may leave the meeting. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Good night, children. Thank you.